So we are required to find the time period of a two-star system which is rotating around the center of mass. So this is a two-body problem because the mass m and 2m will be moving simultaneously. This around the center of mass, this will move like this and this will move like this. Okay, so what we will do is to find the time period, we can either take the longer center of mass approach or we can take a shorter approach. We will convert this into a one body problem using the concept of reduced mass, and this reduced mass is nothing but m1 m2 upon m1 plus m2. So if we put the value, we will get this as 2m by 3. Now what that does is that instead of both the bodies rotating, we use a simplified picture that the total mass, which is 3m, this is stationary, and reduced mass mu is at a distance of d. D is the separation between the two masses. And this reduced mass is the mass that is moving around, and this is stationary. Now this is a much simpler problem to solve, and the time period is given by 2 pi r divided by v. And how do we find v? V is given by under root g m by r. Now interesting thing is that the velocity of this mu does not depend on mu itself. It only depends on the stationary heavier mass. So if we put the values, we will get 2 pi d divided by under root g into 3m upon d. And if you solve this, t will be 2 pi under root d cube upon 3gm. So the answer is option B.